This is a lecture on 3-3, measures of position. So the first thing that we want to talk about is the z-score. A z-score has a formula. It is measured by taking a value that you are interested in analyzing, subtracting from it the mean, the sample mean, and divided by standard deviation. I can do exactly the same thing if I have population information rather than sample information by taking mu and sigma rather than x bar and an s. So what the z-score represents is the number of standard deviations that a data value falls above or below the mean, so away from the mean. In chapter 3, we're just measuring this, and we will study this in greater detail along with empirical rule and other stuff when we get to normal distribution chapter, which I believe is chapter 5 and 6. So we'll start with an example in the book is 3-27. A student scores 85 on an English test, while the mean score of all students was 76. So the mean score was 76, and a standard deviation was 4. So the standard deviation was 4. She also scored 42 on the French test, where the class mean was 36, and the standard deviation was 3. Compare the relative position of the two tests. So we're interested in the standardized score. So how far away were you from the mean? Because in this case, she got a score of 85. This is English. And on the other side, I'll label it as, let's label this as sub 1. And these will be my sub 2s. She also scored 42 on the French test. So my x2, so the score that she actually had was 42. This is French. But the mean is much lower, it's 36. And a standard deviation is 3. So this number, the standard deviation, tells me that the scores do not vary as much as on an English test. I'm interested in how these two are related as far as the position is concerned. So what I'm going to do is I'm going to find the z-score for an English test. I'm going to find the z-score for the French test. My formula is x minus the mean divided by the standard deviation. 85 minus 76 divided by 4. I have the z-score is 2.25. On this side, x, 42, minus 36, minus the mean divided by standard deviation. So 42 minus 36 divided by 3. So z sub 2 is 2. So in a sense, the English is a higher grade than the French because this is 2.5 standard deviations away. This is 2.5 standard deviations, no, 2.25 standard deviations away. And this one is 2 standard deviations away. Now then the positive z tells me that it is to the right. So if I was going to draw this out, I have some kind of a curve. My x bar is 76. The 85 goes in here. I know that this is located x bar plus 2.25 standard deviations. If I was going to draw a similar thing, I have 36 that's in the middle, 42 is to the right, and I know that this is located at 2 standard deviations. All right. I will skip portions of 3-3 because I want to jump to a 5-number summary and IQR. So I am on page 155, so I skipped a few pages over there. What I'm interested in is quartiles. Your data will subdivide into what's called a 5-number summary. You start with a min, the lowest value. You end with a max. Right in the middle is going to be your median. And the median between min and the median is called Q1. And the median between the median and the max is called Q3. What it does is it subdivides into 4 pieces. Piece number 1, 2, 3, and 4. So the first piece is my bottom 25%. This one is the next 25%. Then I have the next 25%. And then I have the next 25%. So sometimes this is very useful in assigning grades because I want to identify my bottom 25%. I want to identify my top 25% and everybody in the middle. The good part is your calculator and the Excel has capabilities of doing that, and I will show you this on the next video. Before we end with examples, I do have one more definition that I want to include in this video. It's called interquartile range, IQR. IQR. Interquartile range. The formula for IQR is Q3 minus Q1. I just have a small example. If Q1 is given to you at 15, this is example 3-35. If my Q1 is given to me at 15 and Q3 is given to me at 22, my IQR is 22 minus 15, which is just 7. Now the IQR is useful in a few different settings, but what we're going to be using it for is to identify outliers. The definition of an outlier is a data value that is either extremely high or extremely low. So basically somebody who is not with everybody else, whether you're too tall or too short, or it's just away from the rest of the data. There is a mathematical way to identify outliers. The outliers, by definition in this book, so this is a way, this is not the way to find outliers, is you want to be smaller than Q1 minus 1.5 IQR. So you find your interquartile range, you multiply that 1.5 and you subtract that from a Q1. If you're any lower than this, you're called an outlier, or larger than the other way around on the other side of the Q3. So you're going to add 1.5 IQR. So what I can do is we'll do a next example, 3-36, in Excel.